The beautiful thing about 2025 is that even if you're a non-developer, you can still build powerful automations for yourself and for your clients. And that's the beauty of AI and platforms like N8N that have reduced the barriers to entry to almost nothing. But there still is one very fundamental skill that you need to master if you want to take the fast track to becoming an AI automation expert. Now, that fundamental skill is called data transformation. You have to understand how data is being transformed inside no-code platforms like N8N to achieve automations. Because fundamentally, an automation is basically just the transformation of data through a bunch of nodes you define as logic inside your specific flow. Now, if that doesn't make any sense, don't worry, because over the next hour and 40 minutes, I'm going to tell you everything you need to know about data transformation, and how you can use the different nodes inside N8N to achieve almost any objective you have when it comes to building powerful automations for yourself or for your clients. So with that being said, let's not waste any more time and get right into it. So an automation generally is just a transformation of data. Because if you think about it, what really happens inside an automation is you have a bunch of input data that come in, they go through the process that you've defined inside your automation, and then they turn into some sort of output data. So realistically, what's happening on an abstract level is X, which is the input data, is being transformed into Y, which is the output data. So generally, automation is just the transformation of data. And so with that being said, it's obviously very important for you to understand how to handle data if you wanted to build successful automations in any platform, especially N8N. And so just in case you guys don't know anything about different data types and you don't know anything about JavaScript, I want to quickly explain what you need to know when it comes to data inside N8N. So generally, there's 5 types of data that you will see inside N8N. These 5 types are number 1, string, number 2, number, number 3, boolean, number 4, an object, and number 5, an array. Now, the top 3 are what we call primitive data types or single value data types, and the bottom 2 are what we call complex or composite data types, or we can also call them multi-value data types. So starting from the top, if you guys ever see any data that's wrapped around quotation marks, anything in between it, that is a string. So generally, we use strings to store text and sentences and words and any sort of unstructured data. So if you guys just have a bunch of words that you want to store as a data point, what you do is you wrap it in quotation marks, and then that becomes a string. But it doesn't only have to be words and letters. A string can even be a number. So if you have the number 9 and it's wrapped in quotation marks, that's not considered a number. That's what we call a string. But if you have the number 9 and it's not wrapped in quotation marks, then that is a number, which is the second type of data that you generally see inside N8N. And the difference between 9 with no quotation marks and 9 as a string with quotation marks is that the computer doesn't actually recognize 9 with quotation marks around it as a real number. So if you were to say 9 with quotation marks plus 8 with quotation marks, the computer would have no clue what this actually means, because these two are strings. They're visually represented as the number 9 and 8 for us, but in the computer, they don't actually represent the number 9 and number 8. So if you wanted to ever do any sort of mathematical formula on numbers, make sure you never have it as a string and you have it as an actual number, because you're otherwise going to get an error. And so when it comes to numbers, any number, positive, negative, or 0, as long as it doesn't have the quotation marks around it, is considered a number inside N8N. And the third data type that you have to worry about is a Boolean data type. Now, a Boolean data type is just true or false. It generally is used to represent conditional values. So for example, if you have a key that says is day, which is basically just trying to say, is it currently day or not? The value for this could either be true if it is currently day, or false if it is not currently day. So if there is any sort of conditions that you want to track, then you can use a Boolean data type to say it's either true or it's either false. And with true and false, just make sure to not wrap it in quotation marks, because then that's not a Boolean data type anymore. That's now considered a string. So the reason why these are simple data types or primitive data types or single value data types is because, as I just said, they're just a single value. So this one single value, this is one single value, and this is one single value. Now the two bottom data types, arrays and objects, they're complex data types because they're what we call multi-value data types. Now the fourth data type is an object. So an object is just a combination of related data. Think of an object similar to objects that you see in the real world. For example, a human is considered an entity or an object. A watch is considered an entity or an object. And these objects inside JavaScript, which is the programming language we use inside NA10, are just used to represent entities similar to how you see entities in the real world. And the reason why we can't just use a string to define a human is because a human would have multiple different factors related to them. So for example, if you wanted to talk about me, it's very hard to put me in just one single value, like one single string or one single number. It's very hard to represent all the qualities about me in one value. So instead, what you have to do is you have to create an object, and that object will have multiple values associated with it. So for example, the object human could have a name, could have an age, could have a height, could have a weight, and so on and so forth. And each of these, let's call them variables, are what we call keys inside an object. And each of these variables or keys would have a value associated with them. So if we're going to be talking about me, for example, Kia, my name is a string Kia. So name has a value string, which is Kia. Now the age would be a number. The height would be a number. The weight would be a number. If you wanted to, for example, say is married, that would be a Boolean statement. So it'd either be true or false. And I am not married, so that would be false. So just as I said, an object is a combination of related data that will define an entity in key and value pairs. So think of key as the actual variable and the value as the value associated with that variable in that specific instance of the object. So when it comes to an object in NA10, an object always looks like this. It starts with a curly bracket and it always ends with a curly bracket as well. And then in between those two curly brackets, it would have a bunch of key and value pairs. So the keys would always be wrapped in quotation marks, similar to a string. So if we have key 1, that's here. Then we have key 2, that could be here, key 3, and so on and so forth. And then you would have I believe this is called semicolons, and you would have the value associated with each of those keys. So in this case, key 1 could be a string, but key 2 could well and truly be a number. Key 3 could be a Boolean. Key 4 could literally be another object. So you can have another object within this object. And I'll give you an example of that shortly. All I want you guys to understand is that an object has multiple different data points inside it, and each of those data points would have a key and a value associated with it. So as I said, in this instance, this one is an object, so it should have a curly bracket, and the key is name, the value is Kia, the key is height, the value is 185, and then you could have another curly bracket at the end, and that would indicate that this is the end of this object. But then you could also have another object, and this object could have name as Joe and height as 165. So in this instance, this object is basically of the same exact type. And the way we've defined that these two objects are of the same type is that they have the same exact keys, so name and height, and the actual values associated with those keys are of the same type. So we have the first key being name, and the value of it is of type string, and the second key is height, and the value of it is of type number. So as long as the keys or the key names are the same, and also the value associated with each of those key names is of the same type, then those two objects could be considered as the same type of object. Now, the next data type, which is also extremely important inside NA10, is what we call an array. So an array is also a multi-value data type because inside one array, you would have multiple different data points, right? But instead of an object, we had to define a key and the value associated with it. In an array, we just have multiple values with no keys. So value number 1, value number 2, value number 3, value number 4, and so on and so forth. And the correct syntax or way to write an array is you would have a square bracket, and then you would have the first value with a comma, then the second value with a comma, then the third value with a comma, fourth value, comma, so on and so forth. And each of these values could technically be of a different data type. So the first one could be a string, second one could be a number, third one could be a Boolean, fourth one could be an object, and so on and so forth. But generally inside NA10, it's best practice if you keep all of the data types of each of the elements as exactly the same. So ideally, you would have all of these as strings, or all of these as numbers, all of these as Booleans, or all of these as objects. So with an array, it's also the same type of thing. You can have any other data type inside each each of its items. So you can have strings, you can have numbers, you can have booleans, you can have objects, and you can even have other arrays inside this array. So we call that a nested array. Now, when it comes to an array, each of the values inside the array is what we call an item inside that array. And it's a little bit weird, but in programming, when we want to talk about the position of an item inside an array, we actually start from position or index. I'm going to write that down. Index 0. So the first item inside an array is the item at index 0. The second item is the item at index number 1. The third item is the item at index number 2. The fourth item is the item at index number 3. And the n plus 1th item would be the item at index number n. So I hope that makes sense. And the reason why that's relevant is because if you wanted to refer to one single value inside an array, so you only wanted to look at the third item or the item at index number 2, you'd write it as the name of the array, and next to the name of the array, you'd have a square bracket, and then you'd put the number of the index of that specific item that you're looking for, and that would be equivalent to whichever value it maps to inside the array. So in this instance, we're looking at the index number 2 item, and if we go have a look, you can see index number 2 is actually the third item, which is C, and so the value of that is actually C. So as I said, technically with arrays, you can have different data types in each of the items, but ideally you would keep them the same inside NA10 because sometimes it breaks the flow if you don't. Now, the reason why looking at these different data types is super important is that in NA10, we handle data using what we call JSON or JavaScript object notation. Now, JSON is just a way to structure data so that both humans and computers can understand it easily, because it's basically just written as a bunch of key and value pairs. Now, taking a look at this example of JSON code, you can see that this entire piece of JSON is an array. And the way you know that is that it starts with a square bracket and it ends with a square bracket. And so this entire thing is just one singular array. Now, inside this array, we have to look for the items of that array. And the way that I know there is 2 items inside this array is that there is one single comma in between these 2 items. And the actual items themselves start with curly brackets and end with curly brackets. And that's how I know this is an array of objects. Because as you can see, we have the outer array, and the outer array has 2 items, and each of those items, as you can see here, are objects. So we have an array of 2 objects. Now, as I said, inside each object, you can have multiple key and value pairs, and these values could be of any data type you'd like. So in this instance, as you can see, field number 1 is a string, field number 2 is a number, field number 3 is a boolean, field number 4 is actually an array. So as you can see, field number 4 has this square bracket and it has 2 values which are both strings. So this is what we call an array of strings. And then field number 5, interestingly enough, is actually an object. So we have an object within another object. And as I said, any object could have any value it wants inside its key value pairs. So this one has a string and a number. Now, the second object is of the same exact type as the first object. And the way I know that is that all of the keys have the same exact name, and the type of data inside each of the keys or inside the value for each key is the same. Because as you can see, field number 1 is a string, field number 2 is a number, field number 3 is a boolean, field number 4 is an array, field number 5 is an object. And even those objects are exactly of the same type because they both have the first field as a string with the same name and the second field as a number with the same field name again. And so these 2 objects are exactly of the same type, but the actual values associated with each of its keys are different. And so although they're of the same type, they're not exactly the same object. So as you can see, this one says string, this one says another string. This one says 123, this one says 789. This one says true, this one says false. This one says string 1, this one says string 3. And so these 2 objects are not exactly the same, but they are the same type. I know that's a bit confusing, so I'll just say are the same type, but are not exactly the same. And so I want you to pause for just a moment and take a close look at this. Understand exactly what's going on with the outer array having 2 items and each of those items being an object, and then that object having multiple fields or multiple keys, and each of those keys having a value, and those values being of different data types. And if you can understand what's going on in this one single box, you will understand almost everything you need to know when it comes to handling data inside NA10. And the reason is that in NA10, we mainly handle data with arrays of objects. So it's exactly what you see here. You usually have an outer array, and then you have objects inside that array as items. And I'll get into that in just a moment. But just to solidify it with a simple example, in this instance, we have another array with 2 items. These items are obviously objects, and the objects have 2 keys. One of them is called name, one of them is called height. Name is a string. This one is Kia. This one, the height is 185. And in the second object, we have the same exact type because the keys are the same name and the data type is exactly the same, but the actual values associated with the 2 key value pairs inside these objects is different. And so these 2 objects, as you can see, they're representing different instances of that object type, but they are of the same object type. And I know putting it in words sounds a little bit confusing, but if you just look at this for maybe 1 or 2 minutes, you would understand it fully. You're going to feel something click in your mind, and once you get that click, you will understand this, and it'll be super simple for you. So now let's take a look at how data is actually handled inside n8n. So if I click on execute workflow, as you can see from the left to the right, each of the nodes, they get this sort of spinning twirly arrow, and that means that the data is currently inside this current node. And then as it goes out of this node to the next one, what happens is the actual node becomes green and it gets this tick at the bottom. And then eventually the data goes all the way and it comes out, and whatever is meant to happen actually ends up happening. But as you can see on these lines, which define the direction in which the data travels, so the data is going from this node to this node, and then from this node to this node, and then from this node to this node. As you can see on top of the actual arrows itself, it says how many items are inside that specific data. And just to show you what I mean, in n8n, data is handled as an array of items. So if you remember what we just discussed, an array has square brackets, and inside those square brackets, it has items separated by commas, right? And inside n8n, the data is actually handled always by an array. So as you can see, we have the add array, which has the 2 brackets of objects. So the array's elements are actually objects. And as you can see, the object inside this array is shown by this curly bracket and this curly bracket. And then inside the object, we have the 2 keys that are associated with that specific object. And so this array in this specific instance only has 1 item because we only have 1 object. You got 1 curly bracket that opens and 1 curly bracket that closes. So as you can see at the top here, it says 1 item. Now this could also have multiple items, and how that would look is that you would just have another object as well. So as you can see over here, now we have 2 items, and the 2 items is the first object and the second object. And I'll talk about how multiple items are handled inside n8n in just a moment. But what I want you to first understand is that generally inside n8n, everything is handled as an array of objects. So at the outer layer, we have an array, and then inside it, we have a bunch of objects. And inside n8n, if you just click on the actual square brackets or on the curly brackets for the object, it will close them and open them. And you can actually click on this clipboard sign and copy the actual object or array that you're trying to copy. So in this case, if I want to copy this object, I'll click on copy selection. If I want to copy the path to this item, I can click on copy item path, parameter path, same thing. And if I want to do it at the array level or for the entire array, I could just do it and do that. But don't worry about what multiple items in n8n mean at the moment. I'll get into that in just a couple of minutes. But for the time being, as you can see, this array only has 1 item, which is 1 object. And inside that object, we have 2 key value pairs. One of them is called blog title, which as you guys can see is a string because you got the quotation marks around it. And the string says why a tree is yellow. And the second one is also a string. And this one says tone is sad. So this is an array of objects, and that object has 2 strings inside it. And so that data point or that item is actually sent to the next node where it gets transformed. So as I said, an automation is just a sequence of actions where the data gets transformed. So inside this node, what's happening is, as you can see on the left-hand side, the input data is coming in, and then it's being transformed through whatever we're defining, and then the output data is coming out. So in this case, the input data was the array of one item, which was an object with blog title and tone. And the output is also an array. And this one also has one item, which is, as you can see, an object, but this object has a bunch of other key and value pairs. So as you can see, the data actually transformed. Over on the left side or in the inputs, the object is completely different to the object on the right-hand side because the keys are different and also the data types inside the keys are different. So I hope this is all coming together and making sense. And automation, as I said, as a whole, is just the transformation of data. And I've said this about 1,000 times, but it's really important for you guys to grasp that simple but fundamental concept. So for you to be able to make the transformations that you want inside each specific node, you have to be able to use the data from the nodes prior to it, right? So for example, in this case, the write blog number 2 node is using the data from the previous node, which is the blog title and tone. And I know you might not understand exactly what's going on over here if you guys are completely new to N8N, but basically what's happening here is we're putting these variables inside a prompt that's being sent to OpenAI and saying, hey, can you please write a blog post about this variable in this variable tone? Your output must be in HTML format. Don't wrap the output. Don't output anything else. So as you can see, what we're doing is we're referencing data from the previous node as a variable. So that's a variable that's for blog title, and that's a variable that's for tone. So although you can't necessarily understand what this means just looking at the code, if you click on this open bar, you can see that it actually shows you what the value of that variable is. So if you turn these variables or these keys into values, it says write a blog post about why a tree is yellow in a sad tone, and your output must be in HTML format for an email body. Don't wrap the output, don't output anything else. And then this is being sent over to OpenAI, and OpenAI is responding to us with this JSON array, which is an array of objects with one object inside it or one item inside it. And that object has a bunch of key and value pairs. First one says index, which is a number. The second one is an object called message. So as you can see, the way I know it's an object is because it starts with a curly bracket and it closes with a curly bracket. Now that object has 2 key and value pairs or keys inside it. The first one is a string called role. The second one is a string called content. And this content is really all we care about. That's the response we got from the LLM. And then actually inside the object, we have another key as well called refusal. This one is saying that it's null. So as I said before, null just means that it hasn't been defined, that we don't actually know, it's non-existent. And then annotations is, as you can see, an array, but it's an empty array. And the reason why I know it's empty is because it just has the square bracket and there's nothing inside it. So it's an empty array. And then we have log probs, which is also null, and finish reason, which is a string in this case. So I hope just by looking at this example, you can clearly understand how data is being handled inside N8N. You have arrays of objects. Each of those objects is an item, and each of those items or objects has a bunch of different parameters or keys with values associated with it. So if that didn't make any sense to you, just pause for one moment, look at exactly what's going on here and try and grasp the concept. Because if you do understand, as I said, this one simple concept about JSON or JavaScript object notation, as I was just talking about, you will easily understand everything you need to know about data inside N8N. So when it comes to calling variables from previous nodes inside N8N, you don't always only have to call the variable from the most recent previous node. So as you can see, for example, in this case, we have node number 1, which goes to node number 2, which then goes to node number 3. Now in node number 3, obviously we can call on the data that's being passed on from node number 2 very simply. The way we do that is that we put these double curly brackets, and double curly brackets tell N8N that, hey, this is an expression. Or basically just let's say, hey, this is a bunch of code. It's not just normal text. And then inside those double curly brackets, once you put this $, it basically means, hey, this is a variable, right? And then once you say $JSON, so if it starts with JSON after the $, this means look at the data that came from the node right before it, right? So if I say $JSON, that means look at the data inside node number 2. And so then I can refer to any specific key and value pair inside the previous node. And I'll get into exactly how you do that in just a second. But what I want you guys to grasp here is that in node 3, I can also refer to data that was in node 1, but not in node 2. And how I'll do that is that I'll do the same thing. I'd say open curly bracket. So this is obviously a bunch of code. And then inside it, I'd say $. $sign would basically say, hey, this is a variable. And then after, I'd put an open parentheses, and then I would put the name of the node I want to reference. I'll close it off, and then I'll put item, and then I'll put JSON, and then I'll put anything else after that. and I'll close off the curly bracket. So actually I realized you might not be able to see this because of my head, but let me see if I can quickly remove my head. There we go. So you should be able to see that now. As you can see, we have open curly bracket, $, parentheses, name of the node, dot item, dot JSON, dot whatever after that. So the idea is that from any specific node, you can call on data from all the nodes prior to it. Whether it's the node right before it, which in that case, you'd put $JSON, or the nodes even before that, which in that case, you have to reference exactly what the name of the node you want to talk about is going to be. And then if you want to use a previous node, just after the name, you also have to put dot item and then dot JSON and so on and so forth. Now, you don't necessarily need to memorize any of this. I'm just giving you context so you can understand everything once we get into it. But realistically, N8N makes this very easy and simple for you. And I'll show you exactly what I mean in just a moment. So looking into N8N again, I want to show you guys exactly how you guys can do all of this inside N8N, and it's super simple. So we've got an example here. In this example, I'm just going to quickly run it so you can see what's going on. Let me run this one. And if you want to run a workflow, you can either click on execute workflow at the bottom here, which will run the entire workflow, or you can just click on the play button above any specific node. And then if you click on the pay button above that specific node, the workflow will only run until that certain point. So as you can see, it's only run until here because the tick stops here. And then these aren't green, meaning that the data is right now in this specific position. It's ready to go on. And then if I were to, for example, come and click on this one, as you can see, the data is now here. This one's been processed. It's waiting to go to the next one. Then if I click on this one, as you can see, this one will then get processed, and it'll be ready to go to the next node and so on and so forth. But I'm going to quickly just bring it back here again so I can explain everything to you. Cool. So just quickly showing you guys what we have until now. In this node, what we did is we defined some random code, and don't worry about what this node actually means and how I did this. I'll tell you more about this node, which is a set field node, in just a couple of minutes. But for the time being, all you need to know is that I defined a bit of fake data in this node. So as you guys can see, in this case, it's still an array of objects. The array has one item. So the way I know that is that there's only one curly bracket, and that's an object. So this object has another array inside it, and this array is called fake data. So if I click on that, you can see that this object only has one key, and that one key is actually for an array. And that array, which is called fake data itself, has two objects inside it. And those objects each have two keys, and the keys are strings that define a blog title and also a tone for that blog title. So just take a look at this for one moment and try and understand exactly what's going on. We have the outer array, then you have one object inside that array. That object has an array inside itself, and the array inside this object has two items. Each of those items is an object with two strings, one representing the blog title and one representing tone. So just pause for a moment and understand exactly what's going on here. Cool. So this one's called fake data underscore 1. And then this one, we've called it fake data underscore 2. It's the same exact structure. We've got the outer array, the object inside it, or basically just the one item. And then we have the array inside that object, and that array has two items. Each of them is also an object. Each have two strings. One represents a blog title and one represents a tone. The only difference between the object inside this array and the object inside this array is that number one, the actual key name for the array is different. And number two, the blog title and tone for each of the values inside the items of the array is also different. So as you can see, in this case, the blog title is what is AGI. In this case, it's why a tree is yellow. In this case, we've got why a tree is green. And in this case, we've got what is ASI. So the idea is I've just defined two random bits of JSON code, or two arrays of objects. Now, the idea of this entire automation is that we're basically getting a blog title and a tone, and we're getting OpenAI to write a blog post about that specific blog title in that specific tone. So with that said, what we'd like to do is be able to reference the data from the previous nodes so that we can send the prompt off to OpenAI and get it to write the blogs for us. So I'm just going to delete these and we're going to go through it one by one. So as I said, when it comes to calling on data from previous nodes, you would want to start with two curly brackets, right? And the second I put two curly brackets, you see that this thing opens and it says JSON. Now, if it's giving me a bunch of options and I can realistically choose any of these options I want, if I just go up and down with my keyword, I can actually read what each of them do as well. But the idea is that this is only starting to realize that this is code because I have this toggle at the top on expression. If I change this toggle to fixed, what you can see is that it now doesn't recognize that this is code, because if I write anything in there, nothing actually happens unless it goes back to expression. So if I remove it and turn it into fixed again, it's thinking that this is just a bunch of text and it doesn't realize that it's code. So if you wanted to make sure that N8N knows that what you're writing is meant to be code, you want to click on expression. And so once you click on expression, anything inside curly brackets is going to be considered as JavaScript code. And so as you can see, df, nd, comma, nf, whatever that says, is obviously not correct JavaScript code. So the actual value that comes out of that variable makes absolutely no sense. And so it's giving me an undefined error. But we obviously know that that's not how we're going to reference previous variables. So I'm just going to remove that. Okay, so let's say what we're trying to do is we're trying to call on a variable or a data point inside the previous node. So the previous node in this one is called fake data number 2. So we know that to do this, first we have to click on expression, make sure it knows that we're going to give it some code, and then we want to put 2 open curly brackets. And then as you can see, the first option that comes up says $JSON. And we know that by writing down $JSON, we're actually going to start referring to the node that just came prior to it. So in JavaScript and inside N8N's coding language, let's put it that way, the way you would nest these functions or nest, let's say, these commands or instructions that you're giving the code is by putting a dot notation. So just putting a dot. It's just waiting. It's like, okay, well, what's next? You want to put a dot. And then once you put the dot, it now knows that you're trying to give it additional instructions. So JSON knows that it's looking at the previous node. And then once I put the dot, it's now giving me the actual fields inside that previous node. So if we take a look at the previous node, once we wrote JSON, we're sitting at this level. And then once we put the dot, it's now looking at the first item. So now that it's looking at the first item, it's saying, hey, the only field I can see, or the only key that I can see in this level is just the one key that's fake data underscore 2. Because as you can see, this object itself only has this one field. And then inside this field, which is one level lower, we have a bunch of other data. But at this stage, we're still looking at it from this first level. So in this first level, N8N is saying, hey, we have fake underscore data underscore 2. So if I put fake underscore data underscore 2, there you go. Nothing really happens. But if I click on dot, then it goes to the next level. So in this case, as you can see, what happened is we didn't see recommendations for any of the fields underneath. And that's obviously an indication that we're making a mistake. And the reason for that is that, as I said, this data point over here, this is an array. And just like I said in the previous section, inside an array, you will reference the items of that array by putting brackets and then mentioning the index of the item that you want to reference. So in this case, once I put the square brackets, you can see that N8N gives me 2 options saying, hey, are you referring to the item at index 0, which is this one here? Or are you referring to the item at index 1, which is this one here? So let's say we want to refer to the item at index 0. I'm just going to write 0, and then I'm going to put a dot. And then as you can see now, it realized that, okay, we're looking at this level now. So in this level, what we have is we have another object, and inside this object, we have 2 fields or 2 key value pairs. One of the fields it's saying is called blog title, which is correct, this one here. And one of the fields it's saying is called tone, which is correct, this one here. So if I were to just write down, for example, blog title, as you can see now in the result section, which is showing what the actual value of that variable is, it's saying it's what is AGI, which is perfect because the value that we were trying to reference said what is AGI. And now that shows that what we're doing is completely correct. And actually a cheat sheet for you guys to follow if you want to know what you're doing is right or what you're doing is wrong is just to click on this expand option. And then inside here, you can see the result right next to the expression. If the result is exactly what you were looking for, then you did it right. Otherwise, you probably did it wrong. And if you actually made a mistake in terms of the code you wrote, like for example, if I put an extra E here, you can see that it turns into undefined because there is no specific key called blog underscore title E, if that kind of makes sense. Just by looking at the colors, if it's green, you know that at least the code you wrote is correct. So then you would actually look at the value inside that green highlighted text. And if the value is what you were trying to reference, then you know you did it completely correct. If it's not, then you probably made a mistake somewhere. Cool. And that was literally how simple it is to refer to a data point in the previous node. I can literally do this again, and this time much quicker. And the quickest way to do it is to, instead of writing it down yourself, just go with N8N suggestion. So it's saying $JSON. We know that that's exactly what we want. We put a dot. It's saying fake data underscore 2, which is obviously this level here, which is perfect. So I'll put enter and then I'll put another dot, and then it's going to give me an error again because it's not making any sense because, as I said, it's an array. So you'd have to mention the exact index. And with that being said, I will delete this. I'll put a square bracket and it's saying, okay, you want to go index number 0, index number 1. This time, let's go with index number 1. So I'm just going to click on index number 1. and then I'm going to delete the extra bracket that came in, put another dot, and now it's saying, okay, blog title or tone, I want blog title. And then just like that, as you can see underneath it, and that says what is ASI, and what is ASI is literally the value of this specific field or key or variable inside the second item of the fake_data_2 array. So I hope this is making perfect sense to you. It's actually pretty simple in practice. Okay, now let's say we want to go one node back. So fake data 2 was the previous node. The node behind it was fake data 1. Now to go to fake data 1, if I just open this up again, as you can see, it shows up on the left side. It's just closed. So if I click the arrow, it's going to open, and that's the data inside fake data 1. So when I want to reference that data, as I said, what you want to do is you want to, again, open up the curly brackets. This time, you don't want to write $JSON. You want to write $, open parentheses, and then as you can see, NA10 already tells you what the previous nodes actually were. So the first node was called trigger manually, which it was. Second node, fake data number 1, which is the one that we actually want to communicate with. And the most recent one is fake data 2, which is this one up here. Now, in this case, what we want is fake data 1. So I'm just going to click on fake data 1. Now, if I press dot, as you can see, it's going to say item, exactly how I said. So it has to be dot item dot JSON. So I'll put item and then another dot JSON and then another dot. And as you can see, this one says fake_data_1, which is this one here, exactly what we want. So we'll click on that and then we'll put another dot. This one's not going to work again. So we'll open the square brackets because it's an array. So we'll choose the item index that we want. So in this case, we want to talk to, let's say, the second item. Let's just put index number 1. We'll delete the additional square bracket it gives us. Click on dot. And actually, just before I click on dot, I want to show you guys something. So on the right-hand side, as you can see in this case, it's saying, I don't actually know what value to give you because what you're giving me is actually an object, right? Because the first item of the fake_data_1 array, which is this one here, is actually indeed an object. So my apologies, I'm at the first index, which is actually a second item, is indeed an object, right? And so because it's an object, it can't just give you a string as an output. It doesn't know which one of the variables or fields inside the object we're trying to reference. So at this point, it's just saying, hey, you're referring to some object, right? And so if I wanted to pull in just one of these strings, what I'll do is I'll put dot, and then it's going to say, okay, which one of these strings you want to talk about? And as you can see, it even gives you the data type on the right-hand side. We want to pull in blog_title. And as you can see, that is the value of the string inside the object, inside the array, inside the overall array. So I know it sounds confusing and there's multiple levels of arrays and objects, but as I said, once you grasp the concept, it's actually very simple. And now it's the same exact concept. If I had 50 nodes all following each other and I wanted to reference one of the very, very early on nodes, I could just put $, and then open brackets, and it will literally show me all of the nodes that came prior all the way to the start of the automation. I can just reference whichever one I want, and then I could choose whatever I want from them. Now, the simpler way to do it is just to actually delete this, put 2 open brackets, and as you can see, it already gives me suggestions for the earlier nodes. So I don't even have to write $, and open brackets. I can just go down, go to earlier nodes and choose whichever node I want. So in this case, let's say fake data 1 again. We'll go item, we'll go .json, we want to go .fake data. You want to put the index. So let's say we go index 0 this time, delete the extra one, and then we go tone. There you can see, sad. So calling on data from previous nodes is a fundamental part of building automations inside NA10. And it's very, very important you understand how you can do it correctly. And as I said, and as I just showed you, it's really not that hard once you grasp the concept. But it probably will take you a couple of times of practicing it to actually understand it as well as I do. So I'd recommend opening up an instance inside your own NA10 and just trying to call on previous objects and see if you can understand it how I've explained it. I'm actually going to give you guys access to this specific template. So open up this template inside your NA10 instance, connect the trigger manually node to this specific flow, and then just try and play around with the expressions until you can understand exactly what's going on. Now, I wanted to show you how to do this more manually so you can actually understand exactly how everything works. But as I said, NA10 is a drag and drop platform. The whole idea about what makes NA10 so popular and so cool and so easy is that the barriers to entry is very low. And that's actually directly reflected even in the part where you actually call on variables from previous nodes. So I could technically sit down and write this $JSON.fake_data_2 index 0 .blog title to call on this specific variable on the left-hand side every single time. So I technically could do that, or I can do the much easier thing, and that's literally just grab the variable I want and then pull it in and drop it where I want it. And that's it. Just like that, you can see these two are exactly the same. Now, if I wanted to go to fake data 1 and drag one of those variables, I could just click on the arrow next to fake data 1, and I could just drag this one, and this should say sad. You can see it literally does exactly what we did down here, and it gives me the value. So you can literally just drag any variable in any node you want, pull it in, place it there, and just like that, it's going to write the exact expression to reference that specific variable. So it's literally so simple. I know I said so a lot of times, but it really is mind-blowingly simple. So there's technically two ways you can do it that are very easy. One is to put the brackets and then just go with NA10 suggestions, or what you can do is just drag whichever data point you want from wherever and then just place it there. And then just one more thing I would like for you guys to know as well. Generally, as I said, this dot notation basically means do something else or go one level deeper. And if you put a dot notation after a specific value or a specific variable, like for example, in this case, we've already called on what is AGI. So at this instance, it's already looking at that specific string. If I put another dot notation now, what I'd have to do is I'd have to define some sort of function. And a function is basically something that happens to that specific variable. So in this case, I can say dot replace all, and this function will literally allow me to replace all of the instances of a certain thing inside that specific string. So just to show you guys what I mean, like in this case, I can say replace all AGI with book. And what happened here is I said, go to this string, which says what is AGI, and then replace all of the instances of AGI or the string AGI with the string book. And the result of that is now we have what is instead of AGI, we have what is book. So that's a function we defined on that specific string. And that's not the only function you can define. There's a lot of different functions you can define for strings and all the different data types that we talked about earlier. So these functions are super valuable when it comes to handling data and transforming data. But just for the sake of giving you a way that you can actually refer to these functions very quickly, I'm not going to go through every single function inside this video and say, hey, this function does this, hey, this function does that, because I think that's actually quite counterintuitive. There's no reason to actually sit down and remember all of these functions. Even I don't remember all of these functions. I just remember like maybe replace all and one or two other ones that are really important to me. What I'll do is I'll give you guys a cheat sheet with all of these expressions in the description down below. So you can literally just hold on to that cheat sheet and it'll tell you exactly what the important functions are, exactly when you should use it, and exactly how you have to use it. So that's probably the easiest way because, as I said, I don't want you guys to sit down and memorize everything, and I want you to just be able to refer to it every single time. And there's also an even easier way to do it, and that is literally just go on Perplexity and ask how you can create a certain expression on NA10. So for example, if you wanted to get a string and do a certain thing with it, you just go to Perplexity and say, hey, I have an expression. This is what the expression currently looks like, which is just saying this is what the variable is. You probably have to give that to Perplexity because it has no clue exactly what variable inside which node you want to refer to because it can't actually see your NA10 instance. And then you basically just say, hey, this is a string. Can you do this, this, and this to it? And then it will give you the updated expression and you wouldn't have to sit down and go back and forth with all the functions and looking at the cheat sheet to try and understand what's going on. That's honestly what I do 90% of the times. So with that being said, I'm just going to show you guys one more thing as well. So if I were to take the workflow back here, so the data is now sitting on this node and it's waiting to go to the next one and go to this node, as you can see, these expressions all became this silvery gray color. And what this silvery gray color means is that the data is still not here yet. And so you have to wait for the previous node to execute before you can actually see whether this is working or not. And this doesn't mean that the code you wrote is incorrect. If the code was incorrect, you'll see it as red. If you see it as gray, it just means, hey, I don't know because you haven't actually ran it all the way. So you'd have to run it until here. And then now you can see that because it's in the previous node and you're referring to the previous node, the expressions have actually turned into green saying, hey, the code is correct. And you can have a look to see what the result of that expression is. If it's what you were expecting, then it's good. But if in this case, for example, it's just saying object of object or it's saying string or whatever it's saying, then you know that you haven't actually gone all the way. You'd put a dot notation and you'll do whatever you meant to do. So just one more thing that's also extremely fundamental when it comes to how data is being transferred across these nodes in NA10. If we were to have multiple items, what happens is each of these items would go through each of these nodes separately one by one. And I can actually show you what I mean. So if I quickly just go in here and I create some fake data that I can reference. So I'm just going to remove that. I'm just going to make it into an object and then remove this. So it's not the most handsome way to write JSON, but I just want to do it quickly. So there we go. As you can see, now we've got one array with two objects inside it. And if I save that As you can see now, it says we've got 2 items inside the array. So the outer array has 2 items. Each of these items is an object with 2 strings, one for blog title, one for tone. And so if I come back here, you can now see that there is 2 items ready to be passed on to the next node. So how n8n actually works is that it will use each of these items one by one. So one of these items, this one first, will come in, it will go through this node, create an output, and then the second item will come in, go through this node and create an output. And that will happen separately, one by one. So just to show you what I mean, I'm going to quickly fix up this prompt. So as you can see, I'm just going to pull in this expression. So as you can see, this one, it's saying refer to the previous node. Inside the previous node, we're trying to pull in the blog title. And in this case, as you can see, it chose the first item, or what is AGI, to show us. It didn't show us the second item, what is ASI. And as I said, that's because it will treat each of these items separately. So first, it will go based off the first item, and then it will go based off the second item. So there's literally no way right now I can try and refer to the second item, because it has to run with the first item first and then run with the second item. And me putting it as $JSON.blogtitle would basically work for both the items. So first, it will run with $JSON.blogtitle for the first item, which is what is AGI, and then it will run with $JSON.blogtitle for the second item, which is what is ASI. So I didn't have to say, hey, go to the first item, hey, go to the second item, for it to know which item we're talking about, because this is at the most outer layer of the array, and each of the items are being treated separately. We're just saying, look for this specific key or this specific variable inside the item that you're using at that instance. So in the first instance, it's what is AGI. In the second instance, is what is ASI. And I'll just show you guys what I mean. So write a blog post about blog title. Your output must be in HTML format. Don't output anything else. And the idea of this automation is what's going to happen after it creates that blog post is it's going to send that blog post over to me via email. So I'm just going to quickly click on execute workflow and we'll see what happens. So as you can see, it's writing the blog posts and then it's actually now sent off the email. So if I open up my email address, you can see that 7:20, 7:21, which is just then, as you can see, 0 minutes ago, we received one email that says, what is ASI, which was the second item in this instance. And then we received another email saying, what is AGI, which was the topic of the first item in this instance. And as you can see, we've got a nice looking blog post here, and we also have a nice looking blog post here. So fundamentally what had happened is each of these items went into a prompt that got sent off to OpenAI one by one, and then OpenAI gave us an answer for each of them completely separately. And they've got nothing to do with each other whatsoever. They don't even know what the other one's about. So the output in this case is also an array of objects. As you can see, it's got 2 items because we had 2 items coming in, and that's always going to be consistent. If you have 4 items coming in, you're going to have 4 items coming out. If you have 100 coming in, you have 100 coming out. And it's the same thing because it's being run 100 times for each item, or one time for each item, and it's giving the output for that specific item. So in this case, we've got an array, 1 object, 2 objects, and this one, array, 1 object, 2 objects. So the first one is going to the first one, and the second one is going to the second one. And as you can see, if I open one of these objects, you can see that the data has literally no similarity between the two because the data has been transformed. One more time, touching on the fact that automation is the transformation of data. But that's the fundamental idea of n8n. We have these arrays. These arrays have objects inside it. Each of those objects are considered one item. Each of those items will go through each of the nodes, be transformed and move along. And that is going to be happening separately for each item. And that's literally all n8n really is. Just figuring out how to transform the data in each node by calling on the data from the previous nodes and having these items go through and eventually getting the output that we're trying to get. And then just one more thing that I've done before, but I haven't actually told you about. As you can see, this node over here is purple, whereas these nodes are green. And that's because with this node, what I did is I clicked this edit button and I edited the output that came out of it. And you can actually do that in n8n. If you want to make some artificial output and you want that output to always stay the same, you just click on save, or in other case, you click on pin, and then it will hold that data as it is every single time. So even if I run this 1,000,000 times, and technically because of the input data, the output should be different, it's not gonna have the output that comes from this input because we've pinned this data here. So this is always gonna stay the same no matter what. And I'm gonna try draw a pin. There you go. So it's always gonna stay pinned no matter what the input data is and no matter what it's actually meant to be. You can either pin it by clicking on pin data, or you can pin it by clicking on the pencil and actually changing the data to whatever you want it to be and then saving it. This one's not going to work because that's obviously not correct JSON. There we go. Okay, cool. So now that we have a good understanding of how data is handled and transformed inside n8n, let's take a closer look at the different data transformation and data handling nodes that n8n gives us access to. So just taking a look at this new workflow that we're working with, it's basically doing the same exact thing. It's just converting a blog title to an actual blog post, and then it's sending that to us via email. But this time, as you guys can see from this logo, it's actually grabbing the blog titles from a Google Sheet called example blogs. And if I show you guys what that looks like up here, it's just a very simple table that says blog title, and it has a bunch of rows, and each row has one separate blog title. So if I come back here and I run this, as you guys can see, what's going to happen is it's going to give me 3 items, and each of those items is just one row from the actual Google Sheet. So in this case, we have row number 1, which is why are some trees yellow, row number 2, which is what is the meaning of life, and row number 3, which is why do we have seasons. And that's literally just 3 rows inside that specific Google Sheet. And these are obviously blog titles, and the blog titles will then be fed into the OpenAI node, which is going to write a blog post and send it to us via email. Very similar to what we saw before. And just to quickly remind you guys one more time, in this case, we have an array. The array has 3 objects, and each of those objects, obviously just one item inside that array, have 2 variables or fields or key value pairs, whatever you'd like to call it. One of them is a number, which is the actual row number inside Excel, and the other one, or Google Sheets, same thing. And the other one is a string, which is defining the actual blog post. And it's the same across item number 1 or object number 1, item number 2 or object number 2, and item number 3 or object number 3. So as I said before, these 3 items, if I just were to pass them on to the write blog 3 node, which is the OpenAI node that writes the blogs, each of these items individually will be run, and each of them will individually create an output, which each of them will individually go to the next node, and each of them will individually be emailed to me. But let's say if we want to do some sort of data transformation in between the Google Sheets node and the Write Blogs node, what we can do, you can click on this plus button here to add a node, and then the nodes that actually transform data inside n8n either sit within this category, data transformation, or this category, flow, or this category, core. So we're going to go through all of them now. First, let's take a look at data transformation. So the first thing you can do if you wanted to transform the data somehow, you'd click on code, and then that would open a new node in between these 2 nodes that literally allows you to define some custom JavaScript or Python code that will allow you to somehow change the data in whatever logic you want. So in this case, it's given you an example. It said loop over input items and add a new field called my new field to the JSON of each one. So if I just run this, you can see that it did exactly what the code was meant to do. It added a new field to each item or each object that says my new field with the value 1. Now, if you wanted to do something completely different, you could just write the code in here, and then the data will go inside that code, and whatever objective you have will be achieved if the code is correct. Now, if you guys don't know how to write code, you have 2 options. The first one is you can go to data transformation again. You can click on AI transform. And what AI transform basically does is it's just the same thing, but instead of you having to write the code, you can write in natural language what you want to achieve, and then the code will get generated for you underneath. So I'm just going to say, for example, loop through each item in the import and add a new field to each item called testing with value 1. So let's just click on generate code, and it's going to grab that, send it off to ChatGPT or whatever they're using in the backend, and that's going to create the generated JavaScript code. And so now technically, if I execute this step, it should take this data through this code and give me the output. So that's exactly what I wanted. I wanted to add 1 extra field called testing and give it the value 1. And so that makes it really, really easy for us, because till now, what I always had to do is I had to go on ChatGPT if I didn't want to write the code, which I never do. And I said, hey, ChatGPT, can you please tell me exactly how I can achieve this objective? This is the input data I have. This is my goal output data. And this is kind of what the transformation is, or at least how I see the transformation happening. And then ChatGPT will write the code for me. I'll come back in here, put it inside the code node and hope that it would execute. And I'll keep going back and forth until eventually it will work. But now, obviously, n8n realized that that's a big hurdle for a lot of people that don't know how to code. And so they put this AI transform node that allows you to literally write down in natural language what you want, and that will turn into custom code. So I really, really love this specific node inside n8n. But it does kind of keep you limited to whatever language model they're using in the backend, and sometimes it doesn't work perfectly. So I still generally go to different LLMs like Claude Thinking or GPT-03 or Grok 3, and I ask them to give me the code, and I'll test all of them and see which one works. I'm going to go through how to do that in another video, so don't worry about it for now. But for probably 90% of cases, you should still be able to just write it in natural language and get the actual JavaScript generated. You just got to make sure that what you're writing down in natural language is actually the correct way for that transformation to actually happen. Cool. So that's the AI transform node. Really cool. And then if we go back to data transformation, you can see that we have one called date and time. So the date and time node actually allows you to do different things with a date and time data type, right? So if I just quickly delete this, there we go. And I add the date and time node. So if I click on it, you can see that there is a couple of things you can do. Let's just say, for example, add to a date. So what this node basically does is it allows us to get some sort of date time input and then do some sort of function to add either a number of days or hours or whatever it is to that date time input, and then give us a new date time output. So technically what I'm saying is, let's say if right now is 7:50 p.m. on the 9th of June, I can do plus 2 hours and it should be 9:50 p.m. on the 9th of June. The way you do date time variables inside n8n is you just make sure it's an expression, put the double brackets, and then as you can see, the second option says now. And now is just the date time representing the current moment. Use the workflow's time zone to make sure that date time is correct. So if I click on now, you can see that the value or the result of this is this date time format data type, which has the date, it has time, and it has the milliseconds, and it has the actual time zone. So it says my time zone is UTC plus 10, which is correct because I'm in Australia. And so now technically what we have is we have this date time variable. Now what we want to do is we want to add a certain number of days to it. So as you can see right now, it's saying it is, as I said, the 9th of June. Let's add 3 days to it and put the output inside a field called new date. If I just run this, as you can see, now it says the 12th of June. So from the 9th of June to the 12th of June, it added 3 days to that specific data. I can change this and make it add a month or add 3 months. If I add 3 months, it should go to September. So the 9th of September. If I change it to, I don't know, hours, or let's do years, I can do 3 years. It will go all the way to the 9th of June, 2028. And if I make it into minutes, it will do an extra 3 minutes. So that will be, right now it is what? It is 7:54. And then in 3 minutes, it's going to be 7:57. Perfect. So the idea of any of these date time nodes is that they allow you to manipulate a date time value. So I'm just going to show you guys another one. For example, if I click on plus, and this doesn't actually have to be connected. Let's just do that. Let's go date and time. So extract part of a date. That's a pretty useful one. So let's say if we turn this into an expression again and put now, what we're trying to do in this instance is we're trying to extract a part of this date. We might want to extract the day or the month or the hour or the minute, right? So the part that we want to extract is the month in this instance, and we're going to put it inside a field called date part. So if I run this, as you can see, what's going to happen is it's going to say this month is the 6th month. So it put the month part of the date time variable of now inside a new field called date part as a number. So if I want to change this, I can just say, call it month in numbers. If I execute that, you can see it's going to say month in numbers. Perfect. Now you can do that same thing with minute, second, hour, day, year. If you just want to, let's say, extract the minute. So let's just change that to minute in numbers. So it's going to say right now it's the 56th minute of the hour, which is correct because it's 7:56. So in the hour of 7 to 8 p.m., it is the 56th minute. If I delete that, I can open this again, go to date and time. We can format a date. So same sort of concept, put an expression, click on now. And the idea is that we can reformat it into any of these formats. So I think US format has one format and the other parts of the world might have another format. So if you want month, month, day, day, or if you want year, year, month, month, day, day. So pretty simple stuff. Now you don't always have to go back and add another node. Sometimes inside the node, it actually gives you access to all of the different operations. So in this case, as you can see, I can just choose from here. So add to date, extract part of the date, which is the ones that we did, format a date, which is the one that we're on right now, get the current date, which literally just gives me the current date. So if I just run this, it says the current date is this date time, get time between dates. So I can say between this and this, how many days is it going to be? And then I can do round the date. So rounding it up or down to the nearest month, day, year, whatever it's going to be. Subtract from a date, I can also do that too. So as you guys can tell, these date and time operations basically just allow you to get a date type value and then manipulate it in a certain way. So for example, if you're running an automation and you want to say, do this in 2 days time, and you want to be able to write a date time for exactly 2 days from now, you could use one of these nodes to say, this is the current date time, let's add 2 days to it. put that in a new variable, and then you can use that new variable in the rest of your flow. Now, I probably never have used these date time nodes. That's because if I were to just, for example, go directly to ChatGPT, what I could do is just inside the expression, I can actually define all of those functions. So I can format it, I can take away from the date, I can add to the date, I can extract part of the date. So literally all of those specific functions you can define just inside the actual expression. And it's much easier that way because the more nodes you add, the more difficult it becomes to make sure the data is being transferred correctly with all the data points that you want. And so I generally find that using the date and time nodes actually makes it a lot harder to build complex workflows, especially if you're building it for clients. So I would probably not recommend using these unless you are absolutely a noob and you really don't know what you're doing. But if you think you're kind of getting the hang of it, I would recommend either just trying to play around with these functions until you know which one is which, or the easier way, which is probably what I do most of the time as well, is you can literally just go on Perplexity and just say, hey, can you please write an expression in NA10 to give me 2 days from now or 3 days from now? And it will literally just write the expression. You can paste it in here. And I know it's become a theme, but I literally use Perplexity 24/7 when I'm building out these flows because it just makes life so much easier. Now, the next node that I want to talk about is the edit fields or set fields node. And this node is literally one of the most important nodes inside NA10. And what this node does, it basically just allows you to define new key value pairs as you're progressing through the data. So for example, I could just say, let's define a new key called name with a value called Kia, right? And I want it to be of type string. So exactly what we talked about till now. And if I execute the step, you can see that it's going to create a new array with an object of one item, and that's going to have one string inside it with the key name and value Kia. And if I want to add another string to this object, I can just say, let's name this string, for example, location, and put in the value as Sydney. So as you guys can see now, the object has 2 strings. One of them is called name, one of them is called location, and the value is Kia and Sydney. And I can just make this infinitely complex. I can add a number and I can say height, and I can do 185. Boom, there you go. As you can see, Kia, Sydney, 185, so on and so forth. And I can just add more and more things. So you can choose whatever data type you want, string, number, boolean, array, or object, all the ones that we went through before. And then you can just add values and make it infinitely complex and define objects that you will send on to the rest of the flow. Now, this doesn't always have to be you creating data out of thin air. If we go back to the example that we had with the multiple fake datas and obviously using them to call on previous nodes, where I showed you guys the different expressions and how they work, the edit fields node could be used to pull in data from the previous nodes to send it onwards. So for example, what we could do is we could say blog title and then also add another one for blog content, right? And blog content will come directly from the previous node because we just created content inside OpenAI. So I can just drag and drop the value of the content variable of the previous node over here. And so it will create a new field called blog content with the value of the content created in the previous node. And then I want to pull in blog title, but blog title is obviously not in the most previous node. Where is it? It's all the way back, let's say here in fake data number 2. So I can just pull in the blog title from here. Boom. And just like that, it's going to give me an error because it says it expects a string, but it got an array. So that's my bad. Let me just run it again and boom, just like that. As you can see now, what we have is we've pulled the blog title from this node here, and we've pulled the content created for that blog title from this node here. And the reason why this is super neat is now we've removed all the BS data that we didn't care about created in all these previous nodes. And we're just progressing with the data that we care about, which is the blog title we gave to OpenAI and the content it gave to us back. And as you can see, because 2 items came in, 2 items also came out. So the first item is obviously the first blog title and the content created for it. And the second item is the second blog title, what is ASI, and the actual content created for that as well. So the set fields node is extremely valuable. It's also very valuable when it comes to building human in the loop systems. And we'll get to that when we build AI agents on NA10. But all I want you guys to know is that this node is extremely valuable and you're going to use it a lot. So coming back to the example where we're grabbing the blog titles from the Google Sheet, as you can see, we've got the 3 blog titles pulled in here. They're in 3 items within the array. Obviously, each item is an object. So what we can do now is if we want to remove some of these items based off a specific condition, we can click on plus, go to data transformation, and then choose filter. So filter is also one that you would use quite a lot. And what filter basically does is that it allows you to define a certain condition or a certain set of conditions that will define which items progress and which items stay or get thrown out. So for example, in this case, let's only keep the item where the row number is equal to 3. But this is not going to work and it's giving me an error. And the reason for that is I haven't defined exactly what type of data that value actually is. So up here, row number is a number, but as you can see, it says A, and A means that we're looking at a string. What we want to do instead is we want to go to number and then go to is equal to. There we go. So numbers are shown with hashtags. So in this case, what it's basically saying is go through each of the items that come in, each of these 3 items, look for the row number of each item. If the row number is equal to 3, keep it. If it is not equal to 3, remove it. So if I come back here and I run this, as you can see on the right side in the output, it's kept 1 item and discarded 2 items. The one that it kept is the one with row number equal to 3, which is exactly what we said. And the ones that it removed are the ones with row number equal to 2 and 4, which are obviously not equal to 3. And so filtering is extremely important, especially when you're dealing with workflows where you have a lot of data progressing through the workflow and you want to make sure that you're removing all the noise and the data that you don't necessarily want to be working with for the rest of the flow. So it's one that you're going to use very often. And when you want to create a filter, all you have to do is choose the variable you want to filter by dragging it into the top field. So let's say row number. If I drag it in here, as you can see, it turns into a value, number 2. So now realistically, what N810 is seeing, it's saying, is number 2 equal to number 3? That's because the first item has number 2 and it's not equal to number 3, and that's why we discarded it. And then once it gets to the second item, it will say, is this value, which is number 3, equal to number 3? It's going to say yes, and then it's going to keep it. So basically what I'm saying is that it's not looking at it from the actual key perspective itself. It's extracting the value and it's comparing the value that's extracted to the value that you're defining below it. And the condition as to whether it's true or false or whether it matches your criteria is defined by clicking on this drop-down menu. First, you have to choose what type of data it is. So if it's a string, it's all of these, number these, date and time, Boolean, array, and object. Now, when it comes to each of these, there's different conditions you can define. So if the string exists, meaning it's not null. If the string does not exist, meaning that it is null. If the string is empty, meaning that the string is basically looking like this, where there's actually nothing in between, it's just empty. If the string is not empty, keep it, which means like if there is obviously something inside the string, if the string is equal to something, if the string is not equal to something, if the string contains something, if it does not contain something, if it starts with something, does not start with something, yada, yada, yada. And the same thing for date and time. Usually it's all basically the same stuff. Is equal to, is not equal to, is after, is before, is after or equal to, is before or equal to. So you can go through each of these and kind of grasp which one is relevant to the condition you want to set. The length of an array being less than or greater than or whatever. And then with objects, exists, does not exist, is empty, is not empty. So define the data type that you're pulling in, and then define the condition that it has to match, and then define the value of that condition. Make sure that top one is on expression and the bottom one is fixed. So unless you want to pull it in from a variable. And then with the conditions, you can also click on add condition and do and or. Meaning if we do, for example, and, it would say, if this condition matches and this condition matches, then keep it. But if this condition matches and this condition doesn't match, or if this condition doesn't match and this condition does match, then remove it. So with and statements, what basically happens is they both have to be true. Whereas with an or statement, what's happening is if this one is true or this one is true or both of them are true, then we keep it. So as long as there is one of these true, we're going to keep it. So you can also make that infinitely complex with more and more conditions. And then you also got this toggle that says convert types where required. And that's basically just saying like if on one place you have 0, another place you have false. 0 is generally equivalent to false. So it's going to convert it to the correct type so it doesn't give you a type error. But if there is any fields that later on get added, because N810 literally updates its nodes and its whole platform every couple of days or couple of weeks. So if there is anything that I haven't gone through, just click on this question mark and it will literally explain exactly what it is and what it does. And if you still don't understand it, just ask Perplexity. Literally, it will tell you everything. So that's the filter node. It's extremely important and I would really recommend you guys get familiar with it. Now, the next one is what we call the limit node. And the limit node is also extremely important. What the limit node basically does is that it allows you to limit the number of items you're passing on to the first X items or the last X items. So in this case, we've got 3 items coming through. We can go inside the limit node and we can just say, keep a maximum of one first item. So that's only going to keep the top item. So if I go back to JSON, you can see that the top item has row number equal to 2, blog title, why are some trees yellow? And the only one that it kept is this one. All the other ones got deleted. But if I change this to last item, it's just going to keep the third one, which is row number 4. Why do we have seasons? And if I were to change it to let's keep the last 2 items, it's going to keep row number 3 and row number 4. And so limit is very, very important when you're building out flows and you don't want to run 1,000 items through it straight away. So if I was working on building a project for a client and that flow had, let's say, 1,000 rows, it was pulling from a Google Sheet and it had to go through each of those rows one by one or all of them together, what I'll usually do is I'll put a limit node and say, let's just grab 1 or 2 to make sure that it can handle multiple items correctly. And then I'll just work with these 2 items to represent those 1,000 items. And then later on, once I've fully built it and I know everything's working correctly, I'll come back and I'll remove this limit, and then it's going to actually start running with 1,000 items. And so the limit node is very practical when it comes to building out flows. Now, the next one is remove duplicates. And as the name suggests, the remove duplicates node just allows you to remove duplicate items. So if I were to click on the first one, this one says remove items repeated within the current input. So if I run this right now, you can see that nothing is going to get removed because all of these items are completely unique. So the values inside the keys or the fields or variables inside each of these items is completely unique. And so none of them got removed. But if I were to go back here and I were to edit this output and let's say just add this as an additional item and click save, as you guys can see now, item number 3 and 4 are exactly the same. So in the input, we have 4 items coming in. And if I remove the duplicate, you can see one of them gets removed. So we go from 4 items to 3 items because the last duplicate item got removed. Now that's the only one I've ever used from the remove duplicates node, but it does also have removing items from previous executions, which I think you would almost never really use, so there's no real point doing it, and you can clear duplication history as well. So not very useful, but if you guys do want to learn about it, you have one of 2 ways. Number 1, ask Perplexity. Number 2, you can click on this docs and that will take you to the documentations for each node. So if there's any node that I didn't go through or that ends up being created after I've created this video, you can literally just always click on this docs and that will take you to the documentation that will explain everything you need to know about that node with all the parameters and all the things you can and can't change. So I'm just going to unpin this. There we go. It goes back to 3 items. And now I'm going to go back to another example just to quickly show you guys the next node we're going to be working with. In this example, we have a set fields node that's just creating fake data again, like we saw before. And this one's got the same thing. So it's just got an array of fake data with 2 items inside it. Now, one thing I want you guys to recognize is that although fake data _1 is an array with 2 items, as you can see, 1 object here and 1 object here, the overarching array or the actual array of items that n8n is passing on to the nodes one by one only has 1 object. So it's 1 item. Now, let's say we're in a scenario where we want each of these items to run separately inside the nodes that come. So we want to separate these 2 objects so that it runs once for this and it runs once for this. The way we'd do that is we would just click out of it and then click on plus, go to data transformation, and then add the split out node. Split out node is also a very, very useful node. And basically what it does is that it allows you to drag a certain array variable that you want to split out. So in this case, we know fake _ data _ 1 has the 2 items that we want to become the overarching sort of items that run through each of the nodes. And so what we can do is we can just pull in this array and we can say, hey, can you please split out the array with name fake _ data _ 1 just by dragging it in. Easy as that. And if I click on execute step, you can see that now what happens is we go from 1 item to 2 items, meaning now moving forward, each of these items or each of these objects will be executed separately. And also what's happening is that the fake _ data _ 1 array is being dismantled and the 2 items are being shown. So technically what we have is over here, we should have fake _ data _ 1, and that is this array here, but it's actually removing that name and it's just giving us the array with the 2 items so we can pass it on. So technically, if you guys ever have items that are inside an array that are inside the object that sit within the outer array, and you want to basically run each of the items within that array one by one, you would just dismantle it using a split out node and you'd pull in the name of that specific array, and then that will break it down into 2 items and you can pass that on to the rest of the flow. So sometimes n8n becomes weird like this, but you can just pull it back down. Now, if we click on plus and go to data transformation, you can see that the next node is called aggregate. And as the image sort of suggests, the logo, whatever you'd want to call it, it's literally the exact opposite as a split out node. So a split out node would get an array or an inner array that sits within the outer array that has multiple items, and it will dismantle it into its specific out items inside the outer array. So it'll just be the outer array and then the items here. I hope that makes sense. Now, the aggregate does the exact opposite. If you have a scenario where you have multiple items in the outer array, the aggregate node will combine them into one array. So I can just put the array here within the outer array. So basically you would have 1 and 2. So these, let me grab another color. These two items go inside a key called array. And so now the outer array only has one item. So it went from 2 items to 1 item. So in super simple terms, split allows you to go from one item to multiple items. If it's an array, you'll basically break down that array. And then aggregate will allow you to go from multiple items into one item by creating a new array. So that's literally all it does. And I can prove that to you in just a moment. If I open up aggregate, you can see that aggregate says, okay, what's the input field name? Let's just say, in this case, we don't want to go with one individual field. We want to go with all data into one single list. So that's just going to grab all the data and put it into one array. And then it's saying, what's the name of the output? Let's just call it the fake underscore data underscore 1 array, which is what we had before. And if I run this, you can see, boom, we went from this, which is exactly what we have now, to this, back to what we had before. So the split out node and the aggregate node literally just neutralized each other. And with the aggregate node, you can also just do individual fields. If you don't want to add all the fields, you can just say, let's just pull in blog title and let's call it fake underscore data underscore 1. And running that, you can see now that will create an array with just the values of that specific key or variable that we pulled in. So now it's just an array of strings. And if I wanted to add more variables or more keys to it as well, I could just add this one. And if I wanted to name it something different, I could also do that, or I could just merge them all together. So as you can see, there's a bunch of things you can and can't do. Like you can, as I said, separate the blog titles and the tone into 2 separate arrays, or you can put it both in the same array or whatever you want to do. But the whole idea of aggregate is to pull variables from the previous nodes and combine it together into a new array. And so the idea is technically to go from multiple items to just one item, or at least less items. Now, the next node I want to talk about is the merge node, which is actually very, very important. So the merge node allows you to grab 2 different streams of data and then combine them together or merge them together in some way. So I can literally grab multiple streams from the same node. That's actually a cool thing about N8N. And I can send that off to different places. And then if I have multiple streams of data going, what I can technically do is I can grab these multiple streams and pull it back into this merge node and have them combine with each other in some sort of way. So if I just keep it as append and don't go to any of the other ones and just say, okay, I want to append 2 inputs, and I click on execute step, as you can see, what happens is it appends or adds the items that come out from this node to the items that come out from this node. And so we have 2 items and 1 item together. That's 3 items appended to each other just like this. So that's the first one, and then that's the second one. Now, if I want to add more input streams, I can just go 3 and I can add more and more input streams if I wanted to. But most of the times I only do with 2. I don't think I've had scenarios where I've had 3 or 4. Maybe I'm wrong, I'm not too sure. But technically what you can also do is you can combine them in different ways. So I generally like to combine them not by matching field, but by position. And what that basically does is that it says, okay, well, the first item from this one should combine with the first item from the other stream that has X variable equal to the item from this stream. So just again, if we have stream 1, stream 2, and this one has a bunch of items inside it, and this one also has a bunch of items inside it, it says, okay, we'll go inside each of these items, look for variable, let's say X, and then see if the value of variable X is equal to another field, let's say variable Y over here. If it is, then combine these 2. If it isn't, then don't combine these 2. So it just basically merges them by finding a matching field. And then all possible combinations basically just does like all possible combinations of everything together. So let's say, for example, if we have, actually maybe I can show you guys by executing the step. There we go. So what it's done is it's done the 2 items times the 1 items, which obviously 2 and 1 is not a great example. It'd probably be better if it was 2 and 2, but technically what it does, it says, okay, if we have I1, I2 on this side, and over here we have I3 and I4. What it's going to do is it's going to do that, and that, which is basically just all the possible combinations being combined. Now, generally where you would use the merge item, or at least where I like to use the merge item, is if I go and I have this really big flow that's like going on for ages, and I want to now pull in a whole bunch of data from a node all the way back here just for neatness. What I'll do is I'll pull this node all the way to this merge node and then pull the previous node as well. And so by doing that, now I have access to both the data that's here and the data that's all the way here. So it kind of allows you to update yourself with previous nodes. Now, as I said, you don't necessarily have to do this. You can kind of still call on previous nodes, but the more complex your flow gets, sometimes the more difficult it gets to just call on a previous node and expect for it to work correctly. Like for example, especially over here, if we have 15 items and down here we only have one item, you're going to see that when you're trying to call on a variable inside these 15 items, it's not going to work correctly because it's going to be like, okay, well, there's only one item here, but over here there's 15. Like, which one am I actually trying to call on? And so sometimes you'll have issues if there's different number of items going through the flow. And the way to solve that is just to bring it all the way back, merge it in, get the number of items to match, and then you can obviously carry on with building the rest of the flow. So that'll probably make a bit more sense once you actually get into it and start building out flows for yourself. But yeah, making sure that the number of items match is pretty important when it comes to NA10. Now, the next node that's super important is the summarize node. The summarize node lets you do a couple of things. And the whole idea of it is to also just work with multiple items. So it will perform functions on multiple items that come in. So if I click into it, actually it might be better if I show you guys the summarize node back on this example. This is just the example where we're pulling in the data from the Excel or from the Google Sheet for the blog title. So if I just click into it, I'll show you what it is again. Blog title with row number. Now, as you can see, there's a stream of 3 items coming in. I can add the summarize node, and the summarize node will allow me to do a bunch of things. So the first thing that it allows me to do is that it allows me to count the number of items that have a value for this specific parameter. So let's say blog title, it would say, okay, well, there is 3 counts of blog title that have values, right? If I want to change it to count unique, it will count and say, okay, there is still 3 unique counts of blog title in the previous items. But if I were to go back here, and if I were to, for example, copy this and paste it here, now the first 2 items have the same value for blog title. So if I count unique it should only tell me that there's 2 unique values. So it's good if you guys have multiple items and you want to find out how many unique values a specific field inside those items actually has. You can do average. Now, average is obviously for a bunch of numbers. So if I do average with blog title, it will probably not make any sense and it'll give me null. But if I do average with row number, it will find the average of the 3 row numbers across the items. So 2 plus 3 is 5, plus 4 is 9, divided by 3 is 3. Perfect. We can do append, which is similar to what we had before. We will append them into a new array called append underscore row number 2 through 4. We kind of saw this before. We can do concatenate. And what concatenate does is it basically just combines it into one singular string. So in this case, as you can see, it says concatenated row number. It grabs row number or the value of row number from each of the previous items and it concatenates it into one string. So if I were to change this from row number to blog title, what it should technically do is it should concatenate or combine all of these into one string, and I can actually define what they're separated by. So right now they're being separated by a comma. You're gonna have why are some trees yellow, why are some trees yellow, why do we have seasons, which is the 3 values here. Or I can change this to, for example, just a space. As you can see now, it turns into a space in between them. So concatenate is the idea of grabbing the values from different items and combining it into one single string. So the maximum, which probably makes the most amount of sense for numbers. So if I pull row number, as you can see, the maximum is row number 4. If I do minimum, it should tell me that the minimum value is 2. If I do sum, it should say it should be 9, if I'm not mistaken. And then if you want to also add in the other variables into the actual final result as well, I can just pull them in here. So I can say, hey, keep blog title, but also give me the sum of the rows. So in this case, basically what it's done is that it's found all the ones that had the same blog title, and then it's added the row number for them. So 2 and 3 is equal to 5. And then it's also giving me the other row number as well. So these are more complex sort of data handling things that you probably wouldn't deal with often. And so I probably wouldn't recommend trying to sit down here and understand how everything works. The best thing and the best way to learn is just to get in there and start building things, and you'll understand as you go. But yeah, most of these stuff you probably wouldn't really use. You'd have to be building something very unique for you to have a use case for this. And honestly, in most instances, it's probably a lot easier just to get ChatGPT to write you some custom code to achieve the objective, as opposed to come in here and be like, how do I achieve this with putting 4 summarized nodes after each other? It just doesn't make any sense. The easiest way just to get AI to write the code for that data transformation to happen, and then move on from there. And then we have some of the other ones, which honestly, these ones are ones that I would say I've not used very often, but I'll quickly tell you what each of them do. So the first one is compression. The idea of compression is that it allows you to create zip folders, or it allows you to open up zip folders. The next one is convert to file, which allows you to convert JSON, which is obviously the way data is being handled inside N8N, to an actual file. So if you want to turn it into, let's say, for example, CSV, HTML, if you want to keep it as JSON, XLS, which is what we use for Excel, and the other data formats here as well. So basically just allows you to convert the data inside N8N to some sort of data format that you can use external inside your computer or wherever. Next one's crypto. The crypto basically just allows you to do cryptographic utilities, but basically what it's saying is that it allows you to like encode your data. And it's good for data security, of course. So if you have like passwords or something you want to encode, and then later on you can decode it and it will make sense. But while it's encoded, obviously no one understands what that actually means. Now the next one is if you want to edit an image, blur the border, resize the image. I don't think I've ever used edit the image. No, actually that's a lie. You'd probably use it inside content creation. And then extract from file allows you to extract data from the file. So it's the exact opposite of what we saw with convert to file. So this one converts from JSON to binary, and this one converts from binary back to JSON. So if you have some sort of file that you're downloading, maybe from Google Drive, and then you want to turn it into JSON data that you can use inside your N8N flow, you would use extract from file. So these two are probably the more important ones till now. The next one is HTML. HTML you'd actually use when you want to build out a report. So I'll actually show you guys what I mean. There you go. So if you click on generate HTML template in the HTML node, it allows you to define some HTML code that you can then use to create an actual report. So let's say, for example, if you wanted to create an invoice, you can create the HTML version of that invoice over here as a template. And then what you could do is you can pull in different variables from different sections inside your N8N flow and then place it inside this template. So you'd have the template written out, and then the actual automation is filling it up. So if you guys want to create any sort of documents, the HTML node is actually very, very valuable. Then we have Markdown, which basically allows you to convert data between Markdown and HTML. So if you click on it, you can see that you can either go from HTML to Markdown or Markdown to HTML. Now, Markdown is basically just a language that large language models use, and it's basically the one that has the hashtags and the stars and all the other weird looking special characters. If you want to convert that into HTML, HTML is what's used inside your email or inside blog posts or web pages, then you can use Markdown to HTML. And if you want to do vice versa, you can use HTML to Markdown. And then rename keys is an interesting one. It allows you to basically just rename the keys. So you can pull in this one, say current key name, row number 2. I want to name it hello. So if I run this and I go to JSON, you can see that now row number 2, instead of being called row number 2, is called hello. So if you want to change the name of the keys, you can. It's an interesting one. And then the last one, which you'd probably use sometimes, it allows you to sort the order of these items. So if you want one item to be at the top or another item to be at the top, you can easily just choose how you want to sort it. So if you just want to sort it randomly, I'm just going to show you what that looks like. This one actually didn't do anything. Now, as you can see this time, it kind of flipped it. So 4 became 1, 1 became 3, basically just flipped 1 and 3, sorry. Or if you wanted to find some custom code to reorder the items, you can. Or the simpler way to do it, as they suggest, is you can put the field name, so row number, and then choose whether you want to do ascending or descending. So ascending would be obviously the smallest one at the top, biggest one at the bottom, and descending would be the biggest one at the top, smallest one at the bottom. So flip it around. So it's just a reorder the order of the items that are coming in. So that's everything inside data transformation. Actually, there was a fair few valuable nodes inside there that you'd probably find yourself using quite often in N8N. Now, the next one is the flow node. So inside flow, we've already talked about filter, so we're not going to talk about that again, but there is one that's very important, and it's called if. Now, the if is the traditional if statement that everyone knows and loves in programming. And what it basically does is that it allows you to just define an if statement or a condition to say, if this condition is true, go this way, and if this condition is false, go this way. So as you can see over here, the output of it has 2 streams, the true stream and the false stream. So the 3 items will go through the 2 streams, and if they match the if statement, or if the if statement holds true, they go from the top stream. If the if statement is false, they go from the bottom stream. So in this case, I can say if blog title, so you do the same thing as I showed you before, you drag in the actual variable and then you choose the condition. So if blog title is equal to, you can just copy this. So I can actually just copy it this way, copy selection, paste it in here. What do we have? Seasons, then it's true. So as you can see, now the true branch only has the third item and the false branch has the other two items because the value of blog title wasn't what we wanted. And so if I come out of here, you can see that the false branch has 2 items and the true branch has 1 item, as you can see. So it's a good way of separating the data that comes in or the items that come in based off some sort of condition. You're going to find yourself using this quite often. Now it's the same deal as what we saw before with the filters. You can add additional conditions with and or statements to make it more and more complex as you'd like. Now what I find myself using quite often as well instead of the if statement is the switch statement. Now the switch statement is very similar to the if statement, but instead of it just having one true or false, it allows you to branch out multiple times to whatever you'd like. So in this case, I can do add a routing rule and add another routing rule. And now instead of just true and false, I can go down 3 branches. And then I can define a condition that will send the data through each of these branches. So for example, if the blog title is equal to why a tree is yellow, go from here. And then I'm just going to say named this branch yellow. And then if the blog title is equal to why do we have seasons, then go here and I'm going to name this branch seasons. And then if the row number is, let's just say greater than 0, go down this one. I'm just going to name it 0. And if I execute this, as you can see, what happens is the top 2 go through. So basically it says the first branch, which is yellow, finds the top 2 items. And then the second branch, which is seasons, finds the bottom item because it matches the condition. But nothing went through the third branch. And the reason for that is that the first 2 branches already took the item. Now, if I wanted the items to also go through the third branch because it matches that condition, I can just click on add options and then add send data to all matching outputs. So now if I run it again, you can see that all 3 items also go through the third branch. So technically we had 3 items come in and we had 6 items go out because 2 items from the top, 1 item from the middle, and then 3 items went from the bottom. So if you turn this off, if it matches through multiple, it will always just go through the first one. But if you turn it on, it will go through all of them that actually do match. And as I said, I love this switch node and you're going to find yourself using it very, very often. Now, the next one that I want to talk about is the loop over items node. And to find this node, you can just click on plus, go to flow, and then you can see it has loop over items split in batches. And I'm super, super passionate about this node. I literally use it almost in every single flow. And what it basically does is that, let's say if I run this, there we go. So as you can see, we have 2 items that are going on in the rest of the flow. Now, what the loop over items node actually does is that it allows you to separate each of these items and have them go one by one. So let's say if there's 2 items up here, it will just grab one of them, go through the rest of the flow, and then it will come back to the loop over items. And then it will grab the second one, go through the rest of the flow. And then if we have 3, it will grab the third one and 4th one and 5th one and so on after that, until eventually it's gone through all of the items one by one. And once all of them went out, it continues from this branch. So basically what you do is you grab all the parts of the flow where it requires all of the items, put it inside the loop branch, send it all the way to the end, and then flip it all the way back into the loop item. So we'll basically just go through each of those items one by one. So basically just like that, go through it. The next one, go through it. The next one, go through it. The next one, go through it. And then eventually, once all of them have gone through, it will go out the done branch with the output from all of the previous items, and it will continue on. So you guys might ask me, what is the point of doing this, considering the fact that if we have 1,000 items, those 1,000 items would execute one by one on the other nodes anyway. So the writes blog node would literally execute 1,000 times individually if I were to just connect this directly and it had 1,000 items. The reason why I do this is that if you don't do this and you just pass in, let's say 150 items to a node, I found that sometimes it actually breaks the workflow and N8N somehow mixes up the items. So you might like pass in item 49 and 50 as the same item, and it breaks the flow in a way that it's kind of annoying if you build something for your clients. So generally the more robust way to do it is to introduce this loop over items, put the rest of the flow inside the loop section, send it back so that one by one it goes through the items and comes back. And the second benefit of adding the loop over items node is that it allows for you to add a wait node, which is the next node I was going to talk about. And the wait node basically just says, okay, once you get to this point, wait for however many seconds or minutes and then continue. And the reason why this is valuable is that if we have 150 items and we're going to send 150 items to OpenAI, or we're going to basically run the OpenAI node 150 times, generally what happens is you get a rate limit from OpenAI, because OpenAI only allows you to call their API X amount of times, let's say per minute. And if you call it more than X amount of times per minute, it's going to say, hey, stop, give me some time, and then run me again in a couple of minutes. And so in scenarios where you have a very large amount of items, the good thing about passing it through a loop over node is that at the end of the loop, you can actually define a wait node. And this wait node would wait however long before it continues. So let's say if we want to pass in 150 and we define wait 10 seconds, it will call the OpenAI node once, go through the rest of the workflow, wait 10 seconds, and then go back with the new item and call the OpenAI node again. So it's waiting 10 seconds at least between each time it's calling the OpenAI node, so you're unlikely to hit that rate limit. And so in scenarios where you have a lot of items, I would 100% recommend building out a loop over item node early on in the flow and just getting the rest of the workflow to go through the loop section, and then eventually at the very end define what happens once the entire flow is completed. And inside the loop over items, you can define how many items you want to send through at once. So in this case, I just want to send through one item. I can actually show you guys what ends up happening. So let's do 15 seconds wait, and then let's run this. As you can see, 2 items comes in, 1 item gets chosen, passes that 1 item to the OpenAI node, which then creates a blog and then sends an email to me with the completed blog. And then it waits. So right now, as you can see, the wait node is spinning. It's going to wait until 15 seconds completes. And then once these 15 seconds completes, it goes back into the loop over items node, which it just did, comes in with the second item, which you can see now here, goes back into write blogs and continues on. So once you have, let's say, 1,000 items, this becomes really valuable because it goes item number 1, wait, come back, item number 2, wait, come back, item number 3, wait, come back, and so on and so forth. So this right here is extremely important if you're building out real client projects. Just don't forget that the loop over items node is a little bit confusing. It has the loop branch and then the done branch. The workflow, or the part of the flow that you want the data to go through, has to go into the loop branch. And then at the very end, whatever output that has can go through the done branch. Just keep that in mind when you're building out your flows. Now, the next node we have to quickly talk about is the compare datasets node. And the compare datasets node just basically allows you to compare 2 different streams of data. So if I click into it, as you can see, you can put in input field A and input field B. And then in the output of it, it will tell you a bunch of factors, like what is only in A, what is only in B, what is different between the 2, and what is the same between the 2. So if you have 2 streams of data, or basically 2 arrays with a bunch of items, and you want to compare these 2 streams and figure out what's the same between them, what's different between them, what's only in one stream and what's only in the other stream, you would basically just pass these 2 in here and it will find it out for you. Generally, this is used for inventory management or stuff like that, but it's also very complex and you probably wouldn't use it if you're a complete beginner. But I want you to keep it in the back of your mind in case one day you are in a scenario where you want to compare 2 streams. Now, the next node that I want to quickly talk about is one that we've talked about before, and this is the execute workflow node. Now, the execute workflow node is super valuable, especially when it comes to building out big enterprise projects, because big enterprise projects end up having, let's say, 150 to 200 plus nodes, depending on how big the project is and how complex it is. Now, on n8n, if I were to connect 150 nodes, I can guarantee you that it will literally become so laggy that it will take me an hour to build out one specific node. It's going to be like this, like it's going to move like a literal snail. And so for you to avoid having it be so laggy, what you'd probably end up doing is you'd have this really big flow separated into multiple flows. So you'd have the parent flow, and then the parent flow would call on these little sub flows so you can divide the nodes in between them. So I've actually got an example here that I can show you. And this example is basically doing the same thing. We have the blog titles and we have a tone and we're trying to create a blog post for them. But instead of having it all as one long flow, like we had up here with obviously data coming in, and then what we've done is we've actually broken it down and sent the part of the workflow that actually creates the blog post and sends the emails into a separate sub workflow. And the way we've done that is that we've just added a execute workflow node. And inside the execute workflow node, we've basically defined which workflow we want to delegate the task to. So in this case, we're delegating it to the workflow called sub workflow example in n8n masterclass. So if we come here, N810 masterclass, sub workflow example, which is this one here. And then in this one, what we have to do, like we've talked about before, is we have to add the trigger node, which is the when executed by another workflow trigger node, which basically just says this automation should only run and be triggered when another workflow calls upon it. So just coming back here, this one sends it off to the bottom workflow, and then the bottom workflow triggers when the top workflow calls upon it. I hope that makes sense. But when you build out the when executed by another workflow trigger, what you have to do is you have to define what data you want to send over. So one thing you can do is you can click on accept all data, and that will just say any data that's being passed across in this stream should be sent to this sub workflow. But I often find that that kind of breaks the flow sometimes, and it adds a bit of variability, especially when it comes to building out AI agents, not these deterministic flows. So I like to define using fields below. And this basically means I just define the exact key and value pairs that I want to receive from that stream. So in this case, I've said the first key is called blog underscore title underscore subflow. The type of it is string. And then the second key is called tone underscore subflow, and the type of that is string. And then over here, when you're building out the execute workflow node, which is sending or delegating the task or the data to the sub workflow, you just have to define what the value of each of those keys actually is. So in this case, the value of the blog underscore title underscore subflow is going to be equivalent to the value of that in the previous node. And then the tone underscore subflow key is going to get the value of the tone from the previous node. So I've basically just dragged this in here, and then I've dragged this one in here. I'm just going to delete that. So I have one instance, and I'll delete this one. Boom, there we go. And now what would happen is if I execute this sub workflow is, as you can see, it's now spinning, meaning it's sent it to the sub workflow and it's waiting for that one to run. So if I come back to the sub workflow and go to the executions, you can see that we have one instance running. So once the sub workflow completes successfully, the data will come back here. And now, as you can see, this data that's been given to us is the output of the Gmail node, which actually sends us the email. So as you can see over here, if we come back, once this refreshes, it says that it succeeded. And as you can see, it wrote the blogs for us and it sent off the email. And that's the output that we saw in the previous workflow. So I've talked about this in a previous video, but as you can see, same sort of deal. The parent workflow has this node that delegates it, gets triggered in the sub workflow, runs in the sub workflow, and then the output of the sub workflow comes back to the parent node and continues on. And then the next node that we have is a stop and throw an error node, which basically just says if it ends up getting to this portion, which you'd probably put it after an if statement, if this happens and it's true, then stop and create an error. So actually, I'll show you guys what that looks like. So let's just say if, boom. So if this happens and it is true, then stop and throw the error of not working. There we go. And then in the if statement, let's just quickly define something. Let's say if this is equal to this, there we go. So if I run the workflow right now, as you can see, what happens is once it gets there, it says problem in node not working, which is the exact error that we defined. The idea is that you want to think in advance if a certain scenario happens and you want to be notified for it as an error and you don't want to continue on with the rest of the flow, you can put an if statement and say, if this happens, then go up here and throw this error. And then you can notify yourself with this error by creating an error workflow, which I've discussed before. Now, the next one is the execution data node. And what the execution data node basically does is that it allows you to save some sort of data point from the previous node or the previous nodes or just any sort of data as a metadata for your current execution. Now, don't forget, execution is just when you run the current workflow, and metadata is basically just data that you can have to actually identify that specific execution. So if you have some sort of ID in the previous nodes and you want that one to be stored alongside your execution so that later on when you want to look for the execution, you can just go to executions, you can filter it, and you can look for that specific metadata in this highlighted data field, and you can find it very easily. So it's good if you guys want to be able to search through a bunch of executions without you having to go and click on them one by one. Now, the next one is FTP, and FTP stands for File Transfer Protocol. And as the name suggests, it's just a protocol in order to transfer files across servers. Now, there's a bunch of different things you can do, like you can delete a file or folder, download a file, list folder, rename or move file or folder, or upload a file. The next one is the N810 nodes. Now, the N810 nodes allow you to do different things within N810, like activate a workflow, create a new workflow, deactivate a workflow, delete a workflow. I haven't really found the use case for this yet that I found intriguing enough to sit down and try and build it. But if you guys have a cool use case for this, please let me know. I'd love to know. The next one is the no operation or do nothing node. And what the no operation or do nothing node, as the name suggests, it literally just does nothing. Whatever data that's coming through it ends up going through it without it doing anything to it. I like to keep these at the end of my flow and just call it done. So I know that, okay, well, this is where the workflow ends and I don't have to add anything more, but realistically, it's a pretty useless node. Now, the last one is the N8N form nodes, which basically just allows you to create different pages inside a form, similar to how you have on Jotform and the other form platforms. I actually show you guys a demo of this because I'm super passionate about the N8N forms and I think they're really, really useful. So I'll just quickly brought in the trigger. So as you can see over here, we have a trigger on form submission. So when someone submits a form, it triggers. And then we have a bunch of nodes that we've defined after. So the first node is basically saying next form page. So this on form submission allows you to define the questions you want to ask on the first page of the form. Then the second one says what questions you want to ask on the second page of the form. And what's super valuable is that you can separate the pages one by one. And because you can separate the pages, you can allow AI in the middle to change the questions based off the answers that the client gives you. So one example of this that I'll quickly show you, if I click on execute workflow, is this form. So what's your name? I'll just say Kia Sam. What's your email address? Just kia@gmail.com. Submit that. We'll go to the next page. Next page is going to ask me what's your goal from booking a call with us. So the idea of this form is to be used when someone wants to book a call with my company. I'll just say, I want to automate social media. So it's pretty broad, pretty hard to understand exactly what this client wants. And then it's going to ask, is this the correct email, the email that I gave? So it's super cool. It's actually pulling it in from the previous page. We can only do that because we have an automation set out. So I'm just going to say yes, submit this one. And then this is where it gets really cool. It says, clarifying, which specific social media tasks are you looking to automate? Content creation, scheduling, engagement, analytics, right? So it's basically diving deeper into what it told me in the previous page. So because they told me they want social media automation, what actually happened inside the workflow is that was sent over to an OpenAI node that were basically just sent over to a large language model. And the large language model was told to ask a clarifying question so we have enough information before we actually book them in for a call. So that clarifying question ended up being, which specific social media task are you looking to automate? Probably could have come up with a better question than that, but let's just say scheduling and then submit that. And then it's going to say, thanks for your inquiry. We've confirmed that we can help you. Please book a call on the following link. And so the idea is like, obviously this is just the beta version. I haven't actually built out the proper flow yet, but you can add additional conditional statements to say, if they match this criteria, then send them directly, which you can do over here, to a URL. And that URL would be my booking page. If they don't match this criteria, don't send them to the booking page. So it's super, super, super valuable. It allows you to build out these forms that are dynamic and that will change depending on the answers that you actually give inside when you're filling out that specific form. And so that was all of the different data handling nodes that you needed to know about. Those nodes collectively with the idea of how data transfers through N8N and how you can transform it through N8N literally has put you in the top 1% of N8N developers. There's a lot of people that claim they know how to work with N8N, but know nothing about how those nodes actually work and how they can transform data throughout the flows. So congratulations. With that being said, I'll see you in the next video.